my God. Okay. All right. I'm going to assume you guys are all actually there and you have no questions. So jumping right back in. Woohoo! Here we go. So we've done many examples of these hypothesis tests. We're going to do some more today, but we're going to focus on hypothesis tests for percentages. We've done them for means. So if I have a claim about the average of something, we know how to set that up. So we're actually, one thing is missing from our ability to fully do this and get it in a journal or something is what a p-value is. So we're going to do a hypothesis test, and we're going to see what the p-value is. In fact, let me just focus on that by itself. That's maybe a better idea. All right, so what the hell is a p-value? Maybe I could, nah, screw it, I don't even know where I put it. All right, guys, so let me see, is this decent with the light? I think so. Let's say I had a one-tail test and I get a Z star of 2.39, right? I don't know if you guys can see that. Let me just stop for a minute. Can anybody type out for me or chat for me or say it? Can somebody tell me what Z star is? Anybody remember what that was? It has nothing to do with David Bowie. It's not Ziggy Stardust somehow. Any Ziggy Stardust fans? No? Anybody know what Z star is? Yes, that's it. Isaiah, look at that. The Z that we get, kick ass. And why do I put a star in it? Why am I so freaking weird? Because the third step, we have a Z-score that tells me where the evidence starts. And then we make another Z-score from our sample. So I just like to call it Z-star to differentiate it. And then I can put a little star on it when I find it. Ooh. So, I mean, that's something I just made up, right? So you're not going to see that anywhere except with me. There went the cap for the marker. So if I get a Z star of 2.39, you guys all have boys and girls out there in TV land, you all have your Z score chart? Can you find the area in that tail? Can you find that area right there for my Z star tail while I get my marker cap? As I block the problem. Sorry. Can you guys do that? I mean, this is old news. Can you look up 2.39, right, and find the area right there in that tail? I'll wait. Well, that might be on the right track, Maddie, but that's definitely not right. I just want the area that's in the tail. Yeah, I see where you got that from. That's the area where? That's the area there. What's the area here? Yeah, dude. That is the p-value. That is the probability that we would get a sample where we did. Now look, do you notice how slow I'm talking now? I normally talk pretty fast. When I talk slow, it's a note to take. That is the probability that that we would get a sample where we got it if the mean was in the right place, if the null was right. Is that a high probability? No, that's less than 1% chance, right? So again, the p-value is the area and the tail or tails of my Z star, right? It's just the area that my Z star makes, right? You guys with me? So that's a note also. That's all a p-value is, the area and the tail or tails that my z star makes. Another way to interpret it, what it really means is it's the probability that you would get a sample where you did if the mean was correct. So again, p-value is the area of the tail of the z star. The way to interpret it is the probability that you would get a sample where you got if the mean was right. So what's more likely? The mean is right or the mean is in the wrong place? Like the null is right or the null is wrong? What's more likely in this case probably is that the null is wrong. I mean, that's such a small probability. Again, it's less than 1% chance. There's a less than a 1% chance that we would have gotten a sample where we did if the mean really is there. So what's more likely? It's actually higher. Okay, I'm really hopeful. I'm really, really hopeful. Whew. So two main ways to look at it. Physically, it's just the area and the tail that your z star makes. Conceptually, it's the probability that you would get a sample where you did, given that the mean was in the right place. Because remember, with a hypothesis test, we assume that the null hypothesis is correct. And then we go, holy shit, what we just did would be so unlikely if the null was right, that it's more likely that the null is wrong. So that's why we reject the null. Right? Is it proof? No, because there's still a chance we're wrong. There's this chance that we're wrong. This is the probability that we reject the null when it was actually true. If you had a 0.84% chance of being wrong, would you feel pretty good? Hell yeah. That's better than most days for me, I'll tell you that. Okay, I'm not seeing anything. So hopefully that made sense. So really, the p-value for you is just one more step. You find the z star, and then you find the area and the tails or tail that it makes. Okay. Now let me add one more little thing on here. If this would have been a two-tail test, I would have doubled this to get the p-value to make it fair. If this would have been a two-tail test, I would have doubled this, and then that would have been the p-value. Okay. All right. I don't see anything. I'm going to assume that means great things. You guys all understood that, which is remarkable. That's really good. Oh, somebody just got here. Shit. Too bad for them. Oh, there's something else I got to do before we can go to this. So that's one thing. That's the p-value. So the smaller the p-value, the more evidence you have gotten that the null looks wrong. Or, is wrong. It's evidence that it is wrong. Okay, maybe. Okay, so here's something else we need for today. We're about to do hypothesis tests for percentages, for proportions, right? If I have a claim about the percentage of something, I claim that more than 80% of Grossmont students hate doing online courses, right? If I have a claim about a percentage, something's going to have to change, right? So the main thing that changes, the biggest thing, there's other changes too, but the biggest thing that changes is the z-score formula. Because normally for means, the z-score formula is this. Right? We've used that formula a dozen thousand times. Okay. Everybody with me? So obviously for percentages, I don't get sigma. They don't give it to me. And of course, I don't care about the means then, do I? I don't give a shit about the means. So here's the thing. Okay. The biggest thing about the z-score formula is what will the standard deviation be? And we already have it. We already have created it. We've already created the standard deviation for percentage sample problems. Believe it or not, the formula for the confidence interval for percentages. Let me compare that to the formula for means. which part of this is the standard deviation? I get a mail? I think so. Which part of this formula, I don't know how you can answer that really. There are some ways you can answer that. Which part of this formula represents the spread? I like it, sort of, yeah, sure. The right side after the what? So again, I don't know how you would answer it. That right there is in the same place as that, right? So these represent the same physical idea. They're both the spread. That is the standard deviation for a percentage problem that you've taken a sample to do. Okay, so you're like, what the shit does that mean, Jeff? Well, let me take this away. If the normal z-score formula is your data point minus the middle divided by the spread, right? That's the one we've been using. Then the one for percentages is going to look like this. It's going to be, I'm going to get a percentage from a sample, right? Good old p hat. And I'm going to compare that to some claimed percentage. Somebody claims the percentage is something. So that's my data minus the supposed middle divided by the spread, which is this dude. Right, you probably can't see that, but this guy goes right there. Okay. Now, if I would have been really smart, which every day I find out more and more that I'm not, I'm just not. I would have put this little worksheet we're going to work on, I would have actually put it up on Canvas so you could actually get it. That would have been great. But oh well, I'm going to throw it up here right now. Any questions before we get into it? This might make more sense as we do it in a problem. Okay, let me share this with you. Where are you? Is it you? Yes. All right. Let me see. What do you guys see right now? It's a problem about what? Anybody? What do you guys see? You guys see a problem related to what? Anybody? We see nothing, Jeff. Class is canceled. There we go. Chicago policeman. I like it. Okay. Thank you. Okay, so let's take a look at this. Let me see. Well, I was going to do something. I forgot. Damn it. Look at number 1. So first read through this. Read through this. Can you find the claim? What's the claim that's being made? Let me zoom in a little bit. Wow. I mean, this one's really nice. I just straight out said the word claim. I mean, my God, don't get used to that. All right. Try to write the claim down in Mathish. Now, be careful. What is this a test about? Is it a test about means or a test about percentages, proportions? It's a test about proportions. So don't put mu. You don't have a claim about no mu. You have a claim about P. You have a claim about the population percentage. So what is the claim? Can somebody type that out or tell me? What's the claim in Mathish? Well, in English, what's the claim? It's that the policeman claims that at most 55% have an unfavorable view of their local police. What does that look like Mathishly in Mathish? Speak, friend, and enter. Elvish. What does that look like in Mathish? The population percentage. I don't know if anybody's still with me. You're all like, this show is boring. Let me turn it to another show. My ratings are bad. All right, so population percentage is at most. Maybe this is what is freaking you guys out. I don't know. How the hell do you write at most? Anybody? What's at most mean? You could be at most 12 to eat off the kids' menu at Denny's. I don't know. Is that true? Whenever I go to Denny's, I'm not exactly coherent. All right. No. Good try, Rudy. At most, less than or equal to. You could be at most this tall to go in the kids section. I don't know what the hell. You can be at most some age, which means you're that age or less. So at most means less than or equal to 0.55. Here's another big thing. Whew. Never use the percentage number. Make it into a real number. What's 55%? 0.55. If you try to use 55, man, you're going to get some freaky ass answers. Right? Okay. Let me stop right there. Is this really that different yet from the other types of hypothesis tests we've done? No, it isn't. Found a claim, saw it in English, rewrote it in Mathish using the right symbol. Now, where's that go? Does that go in for the null or the alternate? Does it go in for the ho or the high? Which spot? Which spot does it go into? You got a 50-50 chance. Or what are you calling me? Oh, yes, it goes in. Let's see if we can do this. Right there. I like it. So then what goes here? P. We got one little old dude in the coffee shop. So what's the other little old dude in the coffee shop think? The opposite of that? What's the opposite of less than or equal to? Greater than. Greater than. Do, 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 do. So how many tail test will this be? One tail or two tail? 1 cube or 2 cubes of sugar? Anybody? Isaiah's like, I ain't answering this. I already answered enough. I got you. You're good. Anybody? Are you guys out there? Is this thing on? Is my Wi-Fi still working? Oh, thank God. Okay. Yes, one tail. Greater than. So all the sample's got to show up above. I think it's greater than. So the sample's got to be up. Right? There's a directional symbol there. So it's got to be in a direction. Now, here's a difference. Here's something different that some of you guys still don't get. Whenever you're dealing with percentages, how do you show that it's normal enough? Don't say n greater than 30. That's for means. What's the test for percentages? Anybody? 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 What's the test? What do you do to test the percentage? Something times something has to be at least something. There's 2 parts to it. Nobody remembers. Okay, well, shit. Are you guys out there? Somebody hit the yes button. Okay, all right, thank you. At least I got Isaiah and Rudy. Oh, there's 5 people. Okay, thank you. Okay, that's good. Thanks, guys. You're all just, yeah, we're here. We just don't have a clue what you want us to say. Well, shit. So remember, it's NP and NQ, right? You got to check NP and NQ. Now, here's the weird thing about hypothesis tests. P is not the thing we get from the sample. That's the P hat. I know what P is. I know what P is. That's a weird statement, but in this problem, what are we assuming P to be? Anybody? What are we assuming the real percentage to be? What do we always assume in the hypothesis tests? We assume that the number from the claim, the number from the HO is correct. We assume that P is 0.55. So why am I not doing N times P hat? Because P hat is an estimate. I never use sample information if I know the population information. And I'm assuming I know what P is. I'm assuming I know the population percentage is 0.55. So what's N times, well, what's N? Somebody just tell me what N is. Let's do that. Anybody just tell me what N is. Don't give me a definition. What number is n in this problem? Yes, thank you. Okay, so it'll be 996. Y'all are all over that one. Times 0.55. And, you know, whatever the hell that is. I'd say 548. I don't know. What is that? Ooh, look at me go. Aha, aha, yeah. Anybody? You guys with me? 547.8. Is that all right? You guys got that? Anybody? And that's greater than or equal to what? What do I check that against? That's definitely at least what? What's the check? NP and NQ have to both be at least 5. Kick ass. So now we just got to check NQ. And Q would be 996 times 0.45, of course, right? If P is 0.55, let me make them look the same. Q would have to be 0.45, and that's going to be 448.2. Is that right? I would really like it if that was right. Let me see, 989, 95, 986. Yes, that's right. Haha. You guys are taking too long. You with your calculators taking too long out there. So what does that mean, what we just did? Those two things tell me what? I'm just doing numbers. I'm just weird. I'm just a math guy, throwing some numbers up there, having a great old time. And you guys are barely awake, trying to suck down some caffeine. Yes, it's normal enough. Thank you. I was just going to keep going. Holy shit, that went crazy. Are you guys able to draw on my board? I'm not going to be happy if you are. Why does it keep doing that? You little jackass. Okay, let's try this again. If it does it again, I'm just going to leave it. Okay. Normal enough. Yes, it is, because it passed the test. So if you have a mean problem, it has to say it's normal, or n's got to be greater than 30. If you have a percentage problem, your check probably should include the percentages. So it's NP, NQ. Somebody keeps getting knocked out. Damn. Step C doesn't change. Oh, by the way, what's really cool about percentages is either they're normal enough and you use z-scores, or they're not normal enough and you don't do anything. T-scores were invented for means. T-scores never come into play for percentages. Okay, so part C is the same as always. I know it's a one-tail test, right? It's a one-tail test. I know alpha. What's alpha? What's alpha? What's alpha? She said. What is alpha? Yes. So 0.005. We can use z-scores. Can you please look that up on your t-score chart? Please tell me what that z-score is. Please. I'm being so nice. Holy shit. I'm just going to deal with it. That's fine, Jeff. Anybody can find it? You use your t-score chart, of course, because we're crazy people. It's a one-tail test with 0.005. So that's the first column, right? One-tail test, 0.005. And of course, z-scores, you just don't stop. Ain't no party like a z-score party, because a z-score party don't stop. So 2.576. There it is, Nantana. Where's the tail? Left or right? Where's the tail? Is it on the left or the right? Yes, because right there, H1 sets up where the rejection region is. It says greater than. So, of course, the whole idea of this problem is that we're trying to show H1 looks right. We're trying to find evidence for H1. H1 thinks greater, so it's got to show up here. Shiboo! Come on, let me do it. And then we figured out that this is 2.576. It's positive because it's up there. Take a minute. Can you write that in English, in words? If Z star is what, then we do what? Here, you guys do that. Let me see if I can't do this. There we go. That's better. Anybody? If Z star is greater than 2.576, what can we do? What are we able to do? What are we able to do? Good Lord, Jeff is going crazy. Sorry. Please excuse my descent into madness in the middle of your course. If I do get in there, what can I do? What does that mean? Who looks to be wrong? Yes, the null looks to be wrong because the null thinks it's in here. So if I do find a sample out there, that is obviously evidence that anybody who thinks it's in here is wrong. So I can reject, good Lord, Jeff. I can reject the null, support the high. I just said the same thing twice. Okay, so that step sets up where evidence starts. And then the next step is, did I get enough evidence? So I'm being very nice here. There's the Z star formula that I showed you earlier. Let's make sure we can all get the same stuff. N we already knew was 996. Can anybody tell me what X is for this problem? What's the number of successes for this problem from our sample? How many successes did we get? Anybody? We asked 996 people, and how many said yes? How many successes did we get? 594. Okay, 594. So then the percentage, of course, is the part divided by the whole. So it's 594 divided by 996. Sure, I made a big deal out of this with confidence intervals, but let's see who remembers something here. What do you guys get? Break it down now. Woo-hoo. Why is p hat not 0.594? It almost is, just because coincidentally something. But it matters how many it's out of. P hat is just not equal to the number you see. That's silly. It's the percentage from the sample. The sample's almost 1,000. That's why this comes out to be almost 0.594. But it actually comes out to be 0.596. Okay. So try to do the formula. Oh, wait. You know what p hat is? What's p, by the way? Let me write that down too. What's p? You knew it from the beginning. We knew it from the very beginning what p was. Yes, good. So now you got everything you need. You know what q is. If you know what p is, you know what q is. We just did p hat. You could do the whole problem. Do it. I'll wait. Strangers in the dark. All right, let me see. Exchanging their clothes. Okay. Oh, yeah. All right, let me catch up to you guys. Let's see. Oh, this is going to be funky. 0.55. Oh, not 55. 0.596. That's my data minus the supposed middle divided by the square root of 0.55 times 0.45 divided by, where is that? 996. Oh, okay. I'm going to see what I get. Let's see what I get. I don't know. Ooh, neat. Anybody get something? I got something. I got something. Yes, I did. Oh, weird. I didn't quite get that, Rudy. Did I write something down wrong? So it should look like this, right? Yeah. So I got 2.92.
Oh yeah, I did them separate. I don't know.
No worries. It's all right, man. You're the only one that gave a guess. So hey, you get marks for that. So let's see. So we get 2.92. Now, look right here. We're going to find the p-value in a minute. When you learn this stuff in statistics, it feels like the p-value is like an extra step. In fact, the way I've taught it sort of makes it come that way. But in the real world, this step here does not really exist for a given problem. Every person that reads a journal article that's in that industry has their own level of significance, their own alpha. So then they can, all I give them is the p-value, and then they can interpret what the answer is. But let's do this right now. What can we say? Did we make it far enough? We got 2.92 for my Z star. Did we make it far enough? Did we make it far enough? Yes, we did. There's 2.576, and we blew that out of the water. If it'll let me draw, there we go. Get out of my way. Stop it. Ah. So there's our Z star, 2.92. So already I know the answer, right? What's the answer to this? Can we reject the null or did we fail? Did we make it into the rejection region? Yes. So can we reject the null or fail? Yeah, we reject it. We don't fail. We reject the null. You can do it, Jeff. Reject the ho. Support the high. We know that's the answer now. That's not sufficient for the conclusion, but that's the quick little answer I can give. Now let's just take a second to find the p-value. You guys find the p-value. Do it. Is that the same one I used? That would have been so freaky. Is it? I don't think so, is it? I used something else, right? No, is that the same one I used earlier? That's, if so, it's so weird. What did I use earlier? Anyway, sorry, you guys are like, he's gone, he's lost it. When I did my example earlier, is that the same Z star I used? 2.92? Does anybody remember? You guys don't remember. I'll have to watch the video later. All right, nobody took notes. That's so fine. It's just freaking me out because I didn't do this problem beforehand. Anyway, it doesn't matter. What do you guys get for the p-value? Anybody? Anybody get this area, right? That's all the p-value is the area right here. Let me do this. Stop it. Anybody get that area? This should sound very familiar to what we did earlier, which has got me tripping. Nobody wants to tell me. Are you guys able to find it? I mean, okay, here's z-score chart, right? Z-score chart, 2.92, right? 2.92, 9982, yes, and then you have to do 1 minus to get the area up there, that's 0.0. Isn't that the same thing we had earlier? That's really tripping me up because I didn't really plan that to happen. So that is the p-value. No, sure, I'll do it over there. There. The p-value is 0.0018. How does that relate to alpha? Is it bigger or smaller than alpha? 0084 earlier? Oh, okay. That's just my bad memory then. Thanks, Isaiah. Is 0.0018 bigger or smaller than 0.005? Is it bigger or smaller? 0.0018. Is it bigger than 0.005 or smaller than 0.005? It is smaller. Yes, thank you. It's smaller. So if the p-value is smaller than the level of significance, the alpha, that's another way to check to see if we pass the test, if we reject the null. If that is true, we can reject the null. And see, I mean, the more out here this tail the star gets, the smaller alpha gets because it's the area in the tail of that thing. So at some point, if it's bigger than alpha, that means that I got out there. I got a big ass tail. If it's smaller than alpha, that means I got out here. That means I actually made it into the rejection region. So I can actually just look at the p-value and figure out the answer. That's what I want to do. Okay, I just remembered something I want to do for you guys. So take a minute and write the conclusion to this while I look something up. See if I can do this. O'Reilly. Why do I sing that song? Why do I sing that song? Okay, that's not good, Jeff. Oh, that's all right. Well, why not? Whoa, funkadelic. I'm trying to look up some studies that have been done. No way. Okay, this, I don't even know if I want to say this to you guys, but oh well, we'll look at this. Let me see if this gives me what I want. Gosh, let me get these out of the way. You guys done with the conclusion yet? Gosh, this is interesting. Come on now, give me what I want. Damn it. Well, shit. Why didn't you guys give me what I wanted? All right, I'll stop. All right. All right, so let's see. Let's try to write this conclusion out. So we made it, right? We made it into the rejection region. We have found sufficient evidence to what? Okay, to what? Reject or support the claim. I mean, what was the claim? Which one is the claim? HO or H1? Which one's the claim? So then I want to use this language right there. I want to use the reject language because I always want the conclusion to talk about the claim. That you don't just have to guess reject or support. Let me just, oh boy, I hope this time it was to say support. No, the claim is the null. I use the language related to the null. I reject the claim. So we have found evidence. Let me in. 2, reject the claim. No, Jeff. Claim that, then you can plagiarize. That at most 55%, at mosty, of Chicago peeps have an unfavorable view of the Popo. Mr. Popo. All right, let me stop there for a minute. Any questions about that stuff? All right, well, I'm desperately trying to find something real quick. I can't, come on. I'm going to find it. Are you, Jeff? Are you? I guess not. I don't believe this. All right, well, shit. I really should have looked this up earlier, but, too bad for all of us. You're all out there going, I just got to put up with this guy just for a few more weeks. Damn, just none of these studies are. You guys doing all right? So let me ask you this. Anybody done any homework that discusses something called types of error? Has anybody hit that yet? No. Okay, that's a quick way for me to make sure where the hell you guys are with homework. Has anybody started on chapter 9 homework? Period. Okay, I like it. Rudy's very honest. I love it. Nobody else? All right, this is remarkable. Why? Nobody? This is so weird. All right, screw it. Screw it. Sorry, guys. I'm just trying to find a study that actually shows me all of the analysis they did. Everything's behind a freaking firewall nowadays. Anyway, sorry. Okay, so we're done with this guy. So let's talk about the types of error. And then I think we're done with chapter 9. Oh, by the way, what's happening on Wednesday? Oh, Isaiah, you have. Okay, we'll talk about types of error. There's a quiz on Wednesday. I'm going to do this. The quiz on Wednesday will only deal with hypothesis tests for means because we just today did the one for percentages. You guys with me? So Wednesday's quiz will be a quiz on hypothesis tests for means. And then probably next week we'll have a quiz on hypothesis tests for proportions. Yay, yay. All right. Probably let me make it official. You're gonna love this, and I don't care. On Monday, yeah, a week from today, we're gonna have a quiz on hypothesis tests for percentages. Oh yeah. Okay, all right. So let's talk about errors. Let's talk about types of error. So there's always inherent in almost any statistical analysis the chance that you did everything perfectly right and yet you are wrong. You are wrong. Your conclusion is wrong. You suck. So, and that's beautiful, to be honest, not the suck part, but that's life. So tell me this. Tell me that. What did we do? What's the fundamental? Can somebody tell me in like the smallest phrase possible? What was the result of this analysis in less than 3 words? You're like, Confused me. No, shit. Let me say, reject the null. No, Isaiah. We can't say that. In fact, to be honest, let me see. Let me say it like this. Before we get an error, the Chicago policeman had the claim, right? Was the Chicago policeman's claim right or wrong based on our analysis? The Chicago policeman's claim looked to be right or wrong?
It was wrong.
Yes. So from our analysis, we can say that there's evidence that the Chicago policeman who made the claim, his claim is wrong, but there's a chance that we're wrong. There is a 0.005, there's a 0.5% chance that we're wrong. There's always a chance we're wrong because maybe we just happen to take a random sample that leaned one way or the other. So what are the types of error that I can make in general? There's only two things I could do. There's only two things I could do in an hypothesis test. Reject the null or fail to reject the null, right? That's the only two things. So tell me this. If I reject the null, when would that have been a mistake? So let me say it like this. Rejecting the null is a mistake if what? You can do it. If I reject the null, when am I wrong? When the null is actually true. I like it. It's a mistake if the null is true. So a type 1 error. Type 1. There's two types. Type 1 is rejecting a true null. Wouldn't that be an error? Wouldn't that be a mistake? Yes. Does that mean that we did our analysis wrong? No. And that's why a lot of people just give up on statistics. They're like, I could do it all right. I could still be wrong. That's freaking life. So you can look at it like, oh man, that's so defeatist. Oh man, I do all this work and I could be wrong anyway. Or you can look at it like, holy shit, this math is honest. It does the best it can. I feel pretty good about what we found, don't I? I mean, I've got a 0.5% chance of being wrong. That's great. I feel pretty good. Could I be wrong? Yeah, but what's the chances of it? Pretty small. So type 1 is rejecting a true null. So then what should type 2 be? The only other thing I could do is fail to reject the null. And when would that be wrong? If the null actually is false. And by the way, Isaiah, be careful. You never say you support the null. We never support the null. We reject it or we fail to reject it, right? Oh, yummy. All right. Failing to reject a false prophet. No, false null. Okay. Don't drink the Kool-Aid, kids. All right. Okay, that's enough on that. So let me see. I did not find what I wanted to find, and that sucks a lot. Let's do this. Here. You guys look at this one. Try to do the first step on this problem here. You guys see this problem? The one about 4-week stats class? You guys see that? I do teach a 4-week stats class. I taught one in January, and I taught one last summer. Just imagine that. Just think about that for a second. Right? In 16 weeks, we get through this. I got through it in 4. And the students, they're just crazy. I don't know. We're all crazy when we do that. So you guys try to do this one. Do the first couple steps. I'll wait. Let's see if I can find something. Come on. Show me the data. Show me the data. Show me the data. Show me the data. Let me see. Come on. Where are you? You can do it. Come on. You can do it. just, okay, I see a lot of confidence intervals. That's nice. You can do it, come on. Ooh, there's some good math in this one, but nope. Yes. Come on. All right. Here, can you guys, if you haven't done this yet, can you write down the problem real quick? And then I'm gonna break you up into groups. Ha 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 ha. And then we'll call it a day soon after that. We might not quite finish this problem, but that'll be all right. So write down the problem. Well, haven't got time for the pain. Oh, I see. Weird. I see. All right, guys. So let me see. I don't know if I really have time for this, but oh well. I do kind of like, so I'm going to assume enough of you guys have the problem written down. Let's try to do this. Let's see. I'm going to let you guys talk with each other for a few minutes. I'm going to try to infuse more of the classes with a little bit of time for you guys to check in with each other. I got 11 people. So let me do this. Okay. So when it comes up, just, I don't know if I've done this with you guys yet, have I? When you get a link on the screen, just click it and talk to each other about the problem. Click the link. I can see who's not really here now. Let's see. If you're out of the room, come here. You got to do something. Hello? Nantana. Click the link. Nantana. Nantana. Oh, you missed it? What do you mean you missed it? You should be able to click the link. How do you mean you missed it? I don't understand. There should be a link there saying, I don't know how to do that. Let me see. Let me try something. No. How did you, I can't do it, Antana. How did you miss it? It's got to still be up on your screen. Let me see. It can't be gone. I don't understand. Let me see. Close the, I can't send it again. I can't. Let me see. It's got to still be there. Oh, well, shit. They're just going to talk for a couple minutes. Did you write down the problem, Nantana? I could be your partner. Oh, she made it. Haven't got time for the pain. Why is nobody doing p-values? This is so weird. This is so weird. Why is nobody doing a p-value? What the fuck? All right, screw it. It's amazing to me. Oh, oh man. Did I just drop an F-bomb? Yeah, I did. Fudge. All right. Welcome back. Let me see. There we go. Welcome back. Some people don't want to come out of their room. Let me see. Isaiah's still in there all by himself. That's weird. All right, well, they got 20 seconds. Here come some people. All right. 10 seconds, and then the room disappears. Here we go. Now Maddie's in there all by herself. That's weird. She just wants to stay in there for a while. There we go. Everybody should come back now. Did everybody make it back? Did you make it out of there? Are you stuck on the internet somewhere? All right, real quick. We'll just do a little bit. Get out of there, Microsoft Store. I don't want you. There we go. Real quick. Anybody get what the claim is? Oops. Chat. Hello, fellow humans. All right. Anybody get the claim figured out? Holy macaroni. What the hell? All right, give me a second. What's the claim, guys? Anybody? P. Yes, the claim is that it's the same. The percentage of students is the same as the professors is 84.5%. I like it. So where's that go? The ho or the high? I'm just going to tell you. Okay. It's got an equal sign, so it goes here. So this one's going to be P. You can do it, Jeff. P, what did I decide on? Not equal to? Let's just close. So how many tail tests will it be? 2-tail test, because it can be up or down. I love it. I love it. And then I tell you what, it's 8:40. Let me see if I can push this. Let me see if anybody starts complaining. Is it normal enough? What'd you guys, anybody do what NP is? What's N? What's N? 322. What's P? Shouldn't have to do any work. No work required. Yes, that's what P is. So what the hell's that? I don't know. I don't know. Is it like 150 to 390? 272? 272.09. Okay. That is definitely at least 5. And then NQ, no, Jeff. And then NQ would be 49.91. Yes. And that is at least 5. So therefore, we can use z-scores. Or we could do something. If that wasn't true, we couldn't do anything. And then just the last thing I'll say, because we're basically out of time. Alpha's 0.10. It's a two-tailed test. So you should be able to find the z-scores. Get in there. Wow. For this problem. Two-tail, 0.10, two-tail. It's going to be that old standard. I think this is the very first one we ever did. 1.645. Right? You guys get that? No? All right. So why don't we go ahead and stop there? We basically finished chapter 9. We're just going to finish this problem, maybe do one more of these kind of problems next time, and then get into the next chapter. Oh, I still need to make a video, sort of like I did with the first part of the practice test. I told you guys I would do that, and I just haven't done that yet. So hopefully I remember to do that. Sort of like an explanation video, not really solutions video, because the solutions are up there already. Everybody saw those? Practice test 3 solutions are up. I'm going to take that as a yes. Okay. All right, guys. That's plenty. Let me see if I can get my hair nice and crazy. That's plenty. I will see you guys later. Okay, let's zoom in and have a question. You got to hang out for a second, or is everybody all right? I'm going to stop sharing my screen. Is everybody, what are you guys doing? There we go. I'm going to start popping the bubbles as you leave. I can pop your little bubbles. There we go. Pop, 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 pop. So everybody else is all right? I'm gonna close the room just so I don't see who's not really here. All right. Bye, everybody.